Hello and welcome. My name's Sam Harley. I'm a Senior Solutions Architect with MongoDB. And today I'm going to be talking about how MongoDB enables real-time data with event-driven architecture. To start, I wanted to really talk quickly about request-driven versus event-driven architecture. It goes without saying that the world moves in real time, and the demands on individuals, groups, and organizations are constantly evolving. Many enterprises and many customers that I speak to on a daily basis are still trying to meet their data needs in ways that don't match this new reality. To keep up with the pace of business, companies must become agile organizations fueled by applications that access, analyze, and distribute data in real time. These applications must run on a data fabric that offers the elasticity to scale up and down when needed, efficiently and cost-effectively empowering people with the insights that they need to do their jobs better. A traditional request-driven data architecture is an anti-pattern to this imperative. Request-driven architectures require users to make requests and wait until that requested information becomes available. An event-driven architecture, on the other hand, proactively makes a stream of data from source systems available in real time. Consuming applications and services can then subscribe to topics of interest and consume this data at their own pace. The key driver today in making this need for real-time data an organizational imperative is the emergence of microservices. Your ability to achieve the benefits of real-time data depends on your development organization rapidly building and deploying new apps, embracing agile ways of working, such as creating a DevOps culture and adopting a microservices architecture. One of the core building blocks of real-time is this concept of an event. And events have three key properties. They're atomic, so something's happened. The event represents that atomic unit denoting what has occurred. They're related, so an event rarely stands alone. It is nearly always part of a stream or a sequence of events. And events are behavioral. The streams or the sequences of these events create an accumulation of facts that capture behavior. So the way to enable companies to operate in real time is to help them capture, manage, and act on events as they occur. The smart organization that captures and acts on these events can predict and proactively prepare for what is to come. A cohesive model has emerged to enable organizations to best leverage events, event-driven architecture. In an event-driven architecture, an application or a service publishes events to a queue, and that particular application or service is known as a producer. A subscribing application or service is a consumer. As we talked about a moment ago, producers proactively make a stream of data from source systems available in real time. Consuming applications and services then subscribe to these topics of interests and, importantly, consume this data at their own pace. There are many elements associated with an event-driven architecture. Event consumers listen for and react to events appended to topics. Event producers generate events that place messages into a message queue or stream. This concept of decoupling has many advantages, including allowing each service to evolve independently, enabling apps to go offline, and making the system elastic so that it can grow and shrink in accordance with ever-changing demand. Microservices communicate with each other through well-defined network-based APIs. The event streaming platform provides the channels and is effectively the glue that binds these microservices together, allowing events to pass between microservices and connecting microservices into complete applications. The database, of course, plays a pivotal role in event-driven architecture. Despite the fact that each microservice may have its own database, the core database provides a central repository, providing an end-to-end view of the business. So let's look at an example of this. In this figure, we can see an illustration of a price change that's occurred. The fuel cost to ship some items has increased, which may impact pricing. This produces events regarding that cost increase event and places them in the message stream where the event queue makes them available. All microservices are listening for any messages of interest. The pricing microservice consumes the event, analyzes it against existing data, and produces events conveying the new pricing into the message stream. The database then pushes these events back to our event queue such that it can be consumed by other services, things like your point of sale system, things like your marketing platform, things like your inventory application. Let's take a look at another example. If we think about fraud detection and remediation and the old way of doing things, effectively what we're talking about here is batch jobs that perform periodic data analysis. An identity thief steals a legitimate customer's credit card information and uses it, probably many times. After running a nightly batch job, the system flags fraudulent charges and notifies the customer. The next time the customer tries to use the card, it's declined. Customer calls the bank, learns the bad news, waits a couple of days for a new card to arrive in the mail. And while worrying about this situation, the customer may leverage another credit card, perhaps from another financial institution that the customer perceives as being less risky moving forward. So not only do you have a whole lot of customer pain, but you've also got a lot of business pain. You've now got to think about the cost to remediate and cover those fraudulent charges. You got to think about things like support time, effort, as well as resources involved. And that emergency intervention process takes engineers away from differentiating work, core projects and tasks. With real-time data, when a legitimate customer goes to use his or her card, the system is constantly checking for potential fraud. Seeing the transaction, the system sends an alert to the customer confirms the transaction is in fact legitimate and can continue to use their card without incident. The transaction is successful. Capturing and acting on events in real time in this particular scenario is the only way to effectively implement fraud detection and remediation. It also delivers a far superior customer experience, resulting in increased customer satisfaction, retention, and also enables things like future upsell as well as cross-sell opportunities for the business. So why MongoDB when you think about microservices and event-driven architecture? With MongoDB, data modeling for microservices is easy. MongoDB helps you to move at the speed that your users demand, giving you the power to launch new digital initiatives and bring modernized applications to market much more efficiently, running reliably and securely at scale, ultimately unlocking insights and intelligence ahead of your competitors. When we talk about MongoDB's intelligent operational database platform or data platform, there are three key tenets that we talk to. So the first one is this concept of the best way to work with data. The document model, the way we store information in MongoDB, is the most natural way to work with data. It is simple for any developer to learn how to code against MongoDB. And JSON documents are the language of APIs, which are how events are commonly communicated between individual microservices and enter the system. The database per microservice model adopted by many organizations today means that you may end up with a lot of databases. With MongoDB, it's not a problem. MongoDB Atlas is our fully managed database as a service offering, making it easy for you to stand up fully managed and automated databases. The second tenet we talk to is this concept of the ability to intelligently put data where you need it. We have built-in redundancy and self-healing capability available as part of MongoDB, ensuring that your business applications are always on for any user at any time. MongoDB can scale out your database horizontally to meet growing data volumes and user loads as you capture new market opportunities. You can also run your operational apps while also serving analytical workloads, driving machine learning initiatives, and using BI tools to unlock insights in real time. And finally, MongoDB provides you with the freedom to run anywhere. The MongoDB community offering, as well as our MongoDB enterprise offering, runs the same regardless of whether you deploy it on commodity hardware on-premise, on the mainframe, self-managed in the public cloud, on a mobile, or on demand as part of our fully managed database as a service offering, MongoDB Atlas. MongoDB is fast becoming the database of choice for developers. The total number of downloads of our platform have grown by a factor of 10 times from 7 million in 2015 to more than 70 million less than 4 years later. In Stack Overflow's 2019 developer survey, MongoDB was named the most wanted database by developers for the 4th consecutive year. We also recently released the MongoDB Kafka Connector, which provides sync and source functionality for MongoDB. So you can use the Kafka Connector to sync information into collections or tables, if you like, within MongoDB from events within Kafka topics. You can also use our source connector. So in real time, as data is changing in your database, using our change stream API, as you're inserting, you're updating, you're replacing, you're deleting documents in MongoDB, in real time, send that information downstream to a Kafka topic. Today, MongoDB is at the core of many event-driven systems. By starting with the core MongoDB data platform and binding in complementary technologies like Apache Kafka, MongoDB provides the data persistence heart of an event-driven architecture. And there are a number of other use cases that we can talk to when we think about enabling event-driven architectures. Things like time series and IoT use cases, predictive maintenance, being able to leverage MongoDB as an operational data layer, or potentially using an event-driven architecture to drive use cases like web activity tracking, as well as log aggregation. The MongoDB connector for Apache Kafka, as I mentioned previously, serves not only as a Kafka sync, but also a Kafka source. So if we take a look at that e-commerce example that we had a look at before, you can also then start to think about leveraging capabilities like our Spark connector, or visualizing data in real time using MongoDB charts, visualizing data in real time using your existing BI tools of choice using our BI connector. Change streams can then be leveraged in order to send data as it's changing in the database back to a Kafka topic such that it can be consumed by other consuming applications. Ticketek, as many of you know, is Australia's largest sports and live entertainment ticketing company. Ticketek chose MongoDB over relational database technologies to power their core ticketing platform. MongoDB Atlas is the data layer for the event-driven architecture that supports their multi-channel ticket sales and distribution network. The platform also supports streaming integrations with customers as well as partners to feed real-time dashboards so that Ticketek can analyze ticket sales trends. Another customer example is EG, which is the UK's leading commercial property data service. EG has made MongoDB the center of its event-driven architecture and runs its business on a microservices-inspired architecture named pods. Each pod maintains a local instance of the data that it needs, pulling that information from a centralized system of record that stores things like transactions, locations, market data, property information, and all data product pods in the system of record runs on MongoDB. AHL is a subsidiary of the Man Group, one of the world's largest hedge fund investment firms. Man AHL uses MongoDB to create a single platform for all of its financial data. The system receives data for up to 150,000 ticks per second from multiple financial sources and writes it to Kafka. Kafka then consolidates and buffers these events before they are stored in MongoDB, where the data is analyzed by quantitative researchers. To sum up, by starting with the MongoDB platform and binding in complementary technologies like Apache Kafka, you can gain the advantages of an event-driven architecture, align your teams more effectively, innovate rapidly, and meet the challenges of ultra-competitive global markets. In short, you can run your business in real time. Thank you very much. I might open it up for questions now.